We've already talked about the definitions of the trig functions, and we've already talked about the reciprocals of the trig functions, but let's go ahead and write them down real quick. First of all, we already know that if I talk about the sine of theta, I know that the sine is the reciprocal of the cosecant. So sine is a reciprocal of the cosecant. Conversely, the cosecant is the reciprocal of the sine. So that's where I get this 1 over sine theta. And again, we've talked about these before, but I just want to make sure that we have them down. Cosine theta is a reciprocal of 1 over secant theta. And again, always put parentheses around the arguments of your trig functions. And conversely, the secant theta is the reciprocal of 1 over, or is the reciprocal of cosine, which is 1 over cosine. Now down to tangent theta. Tangent theta is 1 over cotangent theta. So it's the reciprocal of cotangent. And then the cotangent of theta we can rewrite as 1 over tangent theta. I'm going to add a couple new ones. These are called the quotient identities. And if you're wondering if you need to know all of these, the answer would be yes. After you work with them long enough, work throughout your homework and throughout this lecture, you'll get to know these pretty well. So I wouldn't say you'd have to memorize them because you'll already have them in your head because you've used them so often. But I would start putting these on a note card to refer to often. Tangent theta is equal to the sine of theta over the cosine of theta. Now remember, tangent theta we used to think of as y over x. Now y over r was equal to the sine of theta. X over r was equal to the cosine of theta, if you'll recall. And remember our rule, when you divide by a fraction, you multiply by the reciprocal. So this would flip and these would cancel and be left with y over x. And so it comes right back to sine theta over cosine theta. So tangent is equal to sine over cosine. And then we can also say then that cotangent of theta is equal to the cosine theta over sine theta. Now I don't have all of these memorized. I just know a few of them, so I know my basics, like the reciprocal of sine is cosecant, and then from there I can figure out the rest. And I know that the tangent is equal to the sine of the cosine, and once I have that memorized, I know that the cotangent is the reciprocal of tangent, so that's cosine over sine. So that's kind of the process that I go through to figure these out when I need to. So let's go ahead and look at quite a few examples that you'll see in my math lab using this information. So our first one, let's go ahead and say that we're given that the cosine of theta is equal to -7/8. Okay, so from here, we would want to find, let's say, the secant of theta. Now remember, the secant is the reciprocal of cosine, so all I'd have to do is reciprocate this. Now it doesn't matter whether the negative goes on top or out front, but it should never go on the bottom. Let's go ahead and look at another example. Let's say given secant theta, actually let's do a tangent. Given tangent theta is equal to 4, find cotangent theta. Now we know cotangent is the reciprocal of tangent, but to reciprocate things I need a numerator and a denominator. So 4 is really, or can be rewritten as 4 over 1. So if I reciprocate that to find my cotangent, that would be 1 over 4. So if you have an integer value or a whole number, go ahead and rewrite it as over 1 before you flip it, and it'll make a lot more sense when you reciprocate. So I think we kind of have this idea of reciprocation down, but let's just do a few more of these. Secant theta, let's say, is equal to a -11 over 7. And the reciprocal of secant would be cosine. So let's find cosine of theta. We would find that by reciprocating. And again, the negative stays up top or out front. It does not go to the denominator. We usually don't see negative signs left in the denominator because sometimes they're easy to skip then. And let's look at our last one here. So we've done cosine, tangent, secant. Let's look at cosecant. So cosecant theta equals root 99 over 5. Reciprocal cosecant is sine, so that would mean the sine of theta is 5 over root 99. However, we always rationalize the denominator, so let's multiply top and bottom by root 99, and I get 5 square roots of 99 over 99. Now nothing cancels here, but if it did cancel, I should cancel it. But there's no nothing that'll cancel. But let's look at root 99. There are factors here that are perfect squares. So I'm going to come down here and rewrite this a little bit. 99 can be split up into root 9, root 11. So they're factors that are perfect squares. The square root of 9 is 3. So this is 5 times 3 root 11 over 99. And then the 3 cancels into the 99 33 times. So I am left with, when I'm all simplified here, 5 square roots of 11 over 33. So first of all, you should reduce if you can, and if you can't reduce, check to see if you can simplify the radical. And if you can simplify the radical, you should. For our next examples, we're going to be using decimals. So here, let's go ahead and look at a tangent. So tangent theta is equal to 0.05. So that means we want to find cotangent theta because we know that that's the reciprocal. But again, in order to have a reciprocal, you need a numerator and a denominator. Well, I can't really just put this over 1. So the way I want to do this is I want to rewrite this as a fraction. 0.05 is 5/100ths. That I can reciprocate, but let's go ahead and reduce it first to 1/20th. And so the cotangent of theta would reciprocate to 20 over 1, or 20. Okay, so if you're given a decimal, convert it to a fraction first, reduce the fraction if you can, and then work from there. Now, some other types of problems that we're going to be looking at don't necessarily involve the reciprocal identities, but they do talk about knowing where an angle is located based on given information. So for this example, let's go ahead and look at sine alpha less than 0 and cosine alpha less than 0. And the question is, where is this? Which quadrant is this in? Well, to figure out which quadrant it's in, it would be good to know whether my value of x and y were positive or negative. Well, recall that the sine of alpha is y over r. R is always positive. And so in this case, since this is less than 0, that means negative. So this case, that must mean that y is negative. Now using that same logic, cosine alpha is x over r. R is always positive. X in this case is less than 0. Cosine is less than 0. So this is negative. So x is negative. So what I have here then is my x and my y value are both negative. So where does that occur? X is negative, y is negative in quadrant 3. So using that information, even though I don't know x and y, I can work backward to find that. So sine is negative and cosine is negative in quadrant 3. So it's really important to know about these values of your trig functions and about the values for the quadrants because they come up a lot. Let's go ahead and look at a few other examples. Again, I want to have you go through a lot of examples or have a lot of examples to refer back to while you're working on your homework. Let's go ahead and look at 215 degrees. What I want to do is I want to find the sines, and I don't mean like the sine, S-I-N-E, I mean the positive or negative values of the trig functions. Okay, so let's figure out where 215 is first. And then from there it should come together pretty quickly. So the initial side of my angle is right here. Then I'm going to rotate through. Here I am at 90. Here I am at 180. I need to go to 215. Here's 270. That's too far. So 215 would be about 35 degrees past the 180. So we'll say it's right about here. So we know we're in Q3. We're in quadrant 3. Well, in quadrant 3, we know that my x and my y values are both negative. Okay, so let's go ahead and start making our list up. Let's start with sine. Now remember, r is always positive, so r doesn't really have any influence here. So let's look at the sine of 215 degrees. Remember, that's y over r. Y is negative, r is always positive, so this is going to be negative. Well, if sine of 215 is negative, so is cosecant of 215, because that's the reciprocal of sine. Let's do the same thing for cosine. For cosine, that's x over r. The x value is negative here. The r value is positive. A negative divided by a positive is a negative. The reciprocal of cosine is secant. And so that is negative as well. Our next one is tangent. Tangent is y over x, so that's a negative divided by a negative, would be a positive. And if tangent is positive, so is cotangent. So again, even though I don't know the values of the sine and cosines in terms of their number, I can figure out whether negative or positive, based on where they lie on my Cartesian coordinate system. Let's go ahead and look at another one. This one we're going to be looking at a negative angle. So this one, let's look at negative 239. So negative 239 degrees. And again, we want to find the sines. And this is not like sine, cosine signs, but signs whether they're positive or negative of the trig functions. Okay, so the first thing we want to do is to go ahead and graph this. Now this is a negative 239, so I'll still start on my initial side, but instead of rotating as we did over here on this top one counterclockwise, we're going to rotate clockwise. So here would be negative 90. This would be negative 180. And I want to go to negative 239. So that's going to be going up 59 degrees. So this is another negative 59 degree movement. So my total movement here is negative 239, which puts me in quadrant 2. So in quadrant 2, my x and my y values are going to be negative for my x value and positive for my y value. Okay, so now when I start to find my trig functions, sine of negative 239 degrees, that's going to be y, which is positive, over r, which is always positive. A positive divided by a positive is a positive. And because sine is positive, so is the cosecant. Then we can do the same for cosine. So for cosine, I look at x over r. X in this case is negative. Negative divided by my positive r is a negative. The reciprocal of cosine is secant. So they're both negative. And of course, tangent would be my last one. Now tangent would be y over x, so this would be a positive divided by a negative. Positive divided by a negative is a negative. And because tangent is negative, cotangent, its reciprocal, is also negative. So these are pretty straightforward to figure out. Now, could you do these on your calculator? Absolutely. It's a good way to check your work, but remember, on an exam, you're showing your work. So you're not given credit for whether you say positive or negative. You're given credit for going through, drawing a picture, and explaining how you got your answer. So make sure you always do take the time to do that, because that's where credit comes from. If this problem, let's say, was worth 10 points, if you wrote positive or negative next to each one of these and they were all right, you'd get 0 points, because you have to have your work to justify that. Now, you can't orally tell me your work like I'm doing right now, so you have to make sure you write down your conclusions, draw your graph, write out what you mean and how you drew those conclusions. It's going to be really important that you be able to communicate that clearly. Now, there's some other problems that we can look at too. Again, given basic information about your trig functions, and then based on this information, trying to figure out what quadrant we're in or what are the values of the other trig functions. So for this one, let's say we're given cosecant of beta is greater than 0, and cosine of theta is greater than 0. So actually, let's call that beta, so they're the same angle. And the question is, which quadrant are we in? Okay, let's go ahead and look at one more. So given in this particular case, tangent theta, in this case, is greater than 0, and cotangent theta is greater than 0. Now this particular question, again, is which quadrant? Okay, well, this is kind of an interesting problem. Tangent and cotangent are reciprocals of each other. So once I know one sign, I know the other sign. So this information that cotangent theta is greater than 0 is not helpful. It's not adding anything to the conversation. Now up top, where we had something about cosecant and cosine, that was helpful because that gave me two pieces of information. But cotangent theta being greater than 0, that's just repeating the same amount of information that I have over here. So tangent is positive. Now remember, tangent is equal to y over x or sine over cosine. Well, there's two ways that we could get this to be positive, and that's if I have a positive over a positive or a negative over a negative. So my y over x or sine over cosine setup should be positive over positive or negative over negative. So if I look at xy, I'm looking where that is positive and positive, or where this is negative and negative. So if I draw my Cartesian coordinate system, positive positive would be positive x, positive y. This would be Q1. Now negative negative would be in Q2, or sorry, Q3 down here. So my answer here is not just one quadrant, it's two quadrants. It could be in Q1 or it could be in Q3. And I don't know which one it is until I have a little bit more information. Okay, so this one I can't narrow down to a single quadrant, but I can get it down to two quadrants out of the four listed. Now the next thing we're going to look at are the ranges of all my functions, of all my trig functions. Now remember, domain and range. Well, we're just going to be looking at the range right now, because you can plug in for your domain any possible angle. So that's not the tricky part. The tricky part is the range. Now when we talk about the range, we're going to be talking about set builder notation and interval notation. So make sure when you're doing your homework assignments that you are careful about which one you're answering as. So first of all, we'll have our trig functions. And then we'll have our range given in set builder. And we'll have our range given in interval notation. Now these are the same answers, they're just given in different types of notation. So again, in my math lab, make sure that you're looking carefully to see which one that's asking for. So let's go ahead and look at sine theta first. So if you recall, when we were looking at finding the sines of values or sines of different angles, and we looked at those ratios, the ratios never got to be more than 1. So the range interval for sine is -1 to 1. And we'll see this more when we start graphing these functions. Now for set builder notation, this looks like all values of y, this vertical bar, it's a tall vertical bar, means such that, and basically y is between -1 and 1, and it can be equal to -1 and 1. Now another way to write that, should have left more room here, all values of y such that the absolute value of y is going to be less than or equal to 1. So these are two different ways to write that set builder notation. Let's go ahead and look at cosine next. And cosine is identical. Now I'd like to look at cosecant and secant next. Cosecant and secant. Now remember, sine and cosecant are reciprocals of each other. So if you think about it, if I'm going between -1 and 1, the reciprocal of that would be outside of -1 to 1. So the way I could rewrite this one for cosecant is -infinity to -1, and I can include the 1 because the reciprocal of 1 is 1, the reciprocal of -1 is 1, union, and this means or, 1 to infinity. So reciprocal means I'm on the outside of that. The range set builder notation is going to be a little bit different. This is all values of y such that, and I could put right in here, y is less than or equal to -1, or y is greater than or equal to 1, or all values of y such that the absolute value of y is greater than or equal to 1. They mean the same thing. To me, the first one's a little bit easier to understand. Otherwise, you have to go into the definition of absolute value to clarify these. Now, these aren't as clear right now until we start seeing some graphs, but you need to know this information in order to answer the next few questions. And then we'll build on this in a little bit later sections. Last two we want to look at are tangent and cotangent. Now, if you notice, sine and cosine are the same for the range. Cosecant and secant are the same for the range, and tangent and cotangent are the same for the range. Now, tangent and cotangent, remember, is just the ratio of y to x for tangent, x to y for cotangent, and those ratios could be any numbers. So my range interval is negative to positive infinity for both tangent and cotangent. And then our set builder notation, we can say all real numbers. So all values of y such that we're between negative and positive infinity. And remember, we never bracket infinity. Or all values of y such that y is a real number. Okay, so these are examples of the ranges or the output of a trig function. And yes, we will need to know these. So let's go ahead and look at some examples. So given cosine of theta equals -4. So the question here, is this even possible or is it impossible? So is it possible or impossible? Okay, so if we look at this, theta is called our domain. And I can put any angle I want in here, positive or negative, so there's no restrictions on the domain. The y value is the range. That's the output. So this is my range. So what I'm asking is, could the cosine of just some plain old angle, theta, could that be equal to -4? So if I come up here, and I'm looking at cosine of theta, and I look across, theta's range has to be between -1 and 1. This is not inside that range, so I have to say that this is not possible. So this is impossible, okay? Because it doesn't lie within the range that I've been given. Okay, let's go ahead and look at another example. For this one, I will be given cotangent theta equals, we'll make up some decimal, 3.759. And again, I want to know, is this possible or impossible? Well, theta, just like it was above, is my domain. So this is my domain. And this 3.759 is my range. So I want to know if 3.759 is in the range of cotangent. So if I come up here and I look at cotangent, it says the range of cotangent can be any number from negative to positive infinity. So down here, I'd have to definitely say that this is possible. This is something I could get for an answer. Let's go ahead and look at another example. And again, we're just comparing them to that table. The sine of theta is equal to a -1/2. And at the same time, this has to be true, the cosecant of theta is -2. Okay, so sine of theta is -1/2. Could the sine of theta be -1/2? Well, if we come up here, here's sine, and if we come across, the range has to be between -1 and 1. -1/2 is between -1 and 1, so this is possible. Now, in order for both of these statements to be possible, this also has to be possible with cosecant. So cosecant theta is -2. So let's go look at cosecant. So here, cosecant theta has to be smaller than -1 or greater than 1. Well, -2 is less than -1, so this is also possible. So since both of these are possible, the overall answer then is this whole statement is possible. Okay, and again, that table will help us with that. Now, the next thing we're going to be looking at is we're going to be given a trig functional value. So we'll be given, let's say, the sine or the cosine. And then based on that sine or cosine, I need to find the values of all my other trig functions. So an example of this would be, let's say, given one trig function, in this case, sine of theta equals the square root of 3/7. And one other piece of information. And in this case, we're going to be given that theta is in quadrant 2. Now, I might be given that cosine is positive or cosine is negative or something about tangent, but I have to be given one other piece of information in order to find all the other trig functions. So find the others. Well, our best bet here is to go ahead and do a curve sketch to get us started. So we're in quadrant 2. So our initial side is here. We're going to end somewhere in quadrant 2. And this is my value here of theta. So when I draw this, and again, it doesn't matter where this point is, I'm just going to sketch in some information I know. Sine of theta is square root of 3/7. Well, that is equal to y/r. So my y value, this vertical value, is going to be square root of 3. R is going to be 7. And this x is what I don't know. This x is my unknown right now. Well, the way that I can find x is to use r equal the square root of x squared plus y squared. R is 7. So 7 is equal to the square root of x squared plus root 3 squared. So 7 is equal to the square root of x squared plus 3. I'll go ahead and square both sides to clear the radical. So I get 49 equals x squared plus 3. I'm going to flip this x squared over here because I like my x's on the left. And then subtract the 3 over and I get 46. 49 minus 3 is 46. So I get x equals plus or minus the square root of 46. Now the square root of 46 does not break down. It's 23 times 2. There's no factors there that are perfect squares. So I have to choose between the positive and the negative, and I have to include them both right now. I can't just say it's positive. I have to look at the positive and the negative root. So the reason I know it's going to be negative is I'm in quadrant 2 where x is negative. So x is equal to a negative square root of 46, and I know this because I'm in quadrant 2. Okay, so that's how we can justify our answers and make sure that you're showing all this work on your exams and also your handwritten problems as well. So once I know this, I have it all. So again, my y was root 3, my r is 7, those were given, and then I determined that x was equal to negative square root of 46. So let's go ahead and write out all my trig functions. So the sine of theta was given as the square root of 3/7. And because I know the square root of 3/7 is sine, I also know the reciprocal then is cosecant. So the cosecant of theta is 7/√3. And of course, we always rationalize the denominators, so I have 7√3/3. Okay, next one we're going to look at is a cosine of theta. That's adjacent over hypotenuse if you want to use the right triangle trig, or if you want to look at this in terms of unit circle trig, this would be x/r. So x is negative square root of 46/7. Now because I know cosine, I also know secant. So this would be a -7. And remember that it doesn't matter where the negative goes, either out front or up top. It just can't go in the bottom. So this is -7 root 46 over 46. This doesn't cancel, nothing simplifies, nothing pulls out of the root 46. So this is as far as I can go with that. Last one here would be tangent theta. So tangent theta is y over x or sine over cosine, however you want to look at that. So for this particular case, y over x would be root 3 over negative root 46. And I'm just going to pop the negative up top so we don't lose track of it. And again, I will rationalize the denominator. So this would be a negative square root. 46 times 3 would be 138 over 46 in this case. Now there's no factors of the square root of 138 that will simplify. 12. I'm adding up the 8 plus 3 plus 1 is 12, so it is divisible by 3. But I think that's as far as it will go. I don't think we can pull out any more than that. There's no perfect squares, in other words. And once I know the tangent, I also know the cotangent. So the cotangent of theta would be the reciprocal of this right here, but I'm not going to do that because my numbers are going to get so big. I'm going to come back here to reciprocate. So this would be a negative root 46 over root 3. So I'd multiply top and bottom by root 3. And I'd have negative square root of 138 over 3. That would be my cotangent. So given one of the trig functions and one other piece of information, whether it's the quadrant that you're in or the sine or the cosine value, I should be able to go through and find all the other trig functions. And again, it's a factor of whether you know about positive and negative values for each quadrant and about whether you know about the sine and cosines. Okay, let's go ahead and look at another type of problem as well. In this one, we're going to be given that the cotangent of theta is -1/4, and we're also going to be given that the sine of theta is less than 0. Now, less than 0 means negative. Now, we could find all the trig functions, but in this one, let's just go ahead and find one. We could find all of them, but once we find one, we should be able to find the other ones pretty easy. So again, I want to figure out which quadrant I'm in. So let's go ahead and pop up our Cartesian coordinate system. Now, what information is this giving us? Cotangent is negative. Well, if cotangent is negative, so is tangent. If tangent is negative, that means I'm either in quadrant 2 right here, or I'm in quadrant 4 down here, where the sine and the cosine are different. Well, one other piece of information, we know the sine is negative. So the sine is only negative down here in quadrant 4. So this angle theta is somewhere down here in quadrant 4. Okay, so cotangent would mean that tangent, in this case, is -4 over 1. But I don't know if that negative goes with the top or the bottom. I don't know if it's the y or the x. But I do know that one is negative and one is positive. So that leaves me with the second or fourth quadrants. And then I can narrow that down because this says that the sine is negative. Now my goal here is to find the cosecant of theta. Okay, well, cosecant of theta. Well, cosecant of theta would be the reciprocal of sine. So if I could find the sine, then I could find the cosecant. Well, I already know the sine is negative, so the cosecant also is going to be negative. Okay, so let's start kind of backtracking here. The tangent of theta is -4 over 1, and I'm popping this negative kind of out front because I really don't know where it goes yet, but we'll figure that out here in a second. I've already found out we're in quadrant 4, so down in quadrant 4, remember x, y is always the order of my ordered pair. The x is positive and the y is negative. So this is y over x. So I know for sure that the negative goes with the 4 and the x goes with the positive 1. So I'm giving the ordered pair x is 1, y is -4. So once I know that, I should be able to find r, and then once I find r, kind of work from there. So 1, -4, let's say, is this point right here. Okay, so to find r is the square root of x squared plus y squared. And remember, this comes directly from the Pythagorean Theorem. So 1 squared plus a negative 4 squared. So r is the square root of 17. So here's my triangle. It's kind of getting busy in there. But this is the square root of 17 right here. So what I have then is x is 1, y is negative 4, and r is the square root of 17. So I want to find cosecant theta. Well, I think I'd rather find sine theta first, because I have this one memorized. That's y over r. So y is negative 4 over 17, square rooted over the 17. So that means cosecant theta, then I can come back over here. Cosecant theta is negative square root of 17 over 4. And again, it doesn't matter where that negative goes when I have my ratio written. It only really matters when I'm trying to figure out what quadrant I'm in. So negative root 17 over 4 would be my value for cosecant. And I could go find all the other trig functions as well, but I think we kind of have the hang of this. Okay, so let's go ahead and look at another example. Let's look at when we're given, let's do secant theta. We're given secant theta is negative 7, and that is possible. Go back to your range on the previous page, and you'll see that it is possible to have a secant of negative 7. And in this case, we're given that the sine of theta is greater than 0, which means positive. And we can find all the other trig functions, but I think I would just like to find tangent of theta. But again, once you find tangent, do all the work to find tangent, you really have them all found. Just rewrite the ratios. So what we want to do is sketch up our Cartesian coordinate system. Okay, so sine of theta is greater than 0. That means positive. So if we're positive sine, that means we're up here somewhere. Okay? That's where sine is positive. Sine is negative below there. Now the other piece of information that we're given is that secant is negative. Well, if secant is negative, let's go ahead and put sine is negative here. If secant is negative, so is the reciprocal of secant, which is cosine. So this is saying that cosine is negative. Oops, this is wrong. Sine is positive. So sine is positive, cosine is negative. If I look at my graph, that only overlaps right here. This is where sine is positive and cosine is negative. So based on this information, I know that I'm in quadrant 2. So these two pieces of information together mean quadrant 2. So cosine is positive, sine is negative. X is positive, y is negative. So let's go ahead and rewrite this so we know we're in quadrant 2. And I'm just going to pop in a point here. I really don't know exactly what's going to happen yet with those points, but it's a good spot to get me started. Okay. So let's start with secant. So if secant theta is negative 7, we could rewrite that as negative 7 over 1. Now cosine is the reciprocal of secant. So the reciprocal of negative 7 over 1 is negative 1 over 7. Okay, so cosine is x over r. Now I know r is always positive, so this negative definitely goes with the x. So I know x is negative 1, and I know r is 7. So x is negative 1, r is 7. Now I need to find y. Well, I can find y by using our distance, our Pythagorean identity, or Pythagorean theorem here. I have 7 is equal to the square root of negative 1 squared plus y squared. So I'd square both sides, so I get 49 equals, when I square both sides, the square root sign goes away. So I'm left with 1 plus y squared. Subtract 1 from both sides and I get y squared equals 48. So y would equal plus or minus the square root of 48. But the square root of 48 is 16 times 3, and the square root of 16 is 4. So this is 4 root 3. But in quadrant 2, I know that y is positive, so this is 4 root 3 because I'm in quadrant 2. So again, a lot of these things you can plug into your calculators to figure out, but you have to have the work in order to get any credit at all. So here we have y equals 4 root 3. Now what were we trying to do anyway? I forget. Oh, tangent. So tangent of theta is y over x. So y in this case is 4 root 3. X is -1, so this is -4 root 3. That would be my tangent of theta. And of course from here I can find all of the other values as well. Let's go ahead and look at one last problem that you'll see in your homework set, and then I want to review or go back through and point out some Pythagorean identities and some other things that would be handy to know in the future. They want you to use them in this section, but I think there's easier ways to do these problems, but I want to make sure you're aware of them and also some notations. Okay, so for this last problem, we're going to say that we're given that theta is between 90 and 180 degrees. So that's what this notation means, it's between. What we want to do is find the sine. And this is not the SINE, this is the SIGN, meaning positive or negative, of the secant. And the secant is theta plus 180 degrees. Okay, so again, we want to know, is this positive or negative? Well, the important part here will be to figure out which quadrant we're in, because once we figure out what quadrant we're in, we're good, because we know what secant is. It's a reciprocal of cosine. And I know what cosine is, that relates to the x. So that will figure out for me which quadrant I'm in pretty quickly. Now it says theta is between 90 and 180. So if we're in between 90 and 180, that means I'm in here. I'm not on the quadrantial lines. I'm somewhere in here. Well, let's say I'm here at 91. So let's say I'm right here at 91 degrees, right past this line. If I take and I add 180 degrees to that, what quadrant will that put me in? So 90 plus 180 is going to put me at 271. So 91 plus 180 is going to put me at 271 degrees. So the the smallest possible angle I could be would be like 90.000001, but I'm going to go with 91. That puts me right here at 271 if I add 180. Now, the largest I could get and not hit 180, and again in terms of integers, not decimals, would be 179 degrees. So if I take 179 degrees plus 180 degrees, I get clear over here at 359 degrees. So this would be the 179 plus 180 is 359 degrees. So what ends up happening then is once I add that 180, I'm over here in quadrant 4. So now as soon as I know I'm in quadrant 4, then I can say the secant of this theta plus 180 is in quadrant 4. The secant, remember, is the reciprocal of the cosine, and I know the cosine in quadrant 4 is positive, the sine is negative, so this is going to be positive, greater than 0. So 1 over a positive number is a positive number. So the secant of theta plus 180 degrees is positive. It's greater than 0. So you can logic your way through that pretty quickly. Okay, so to end up with, we're going to talk about some very, very important Pythagorean identities. You're going to use these a lot in this class. And if you go on to calculus, the calculus sequence, Calc 1, Calc 2, Calc 3, or any of those calculuses, you will be using the Pythagorean identities a lot. The Pythagorean identities. Now, identity is something that is true for no matter what numbers you put in it. So these are true for no matter what angles we put in it, or what, whether they're in the degrees or radians. And we haven't really talked about radians yet, but these Pythagorean identities work for either. So let's go ahead and start with something we're familiar with. X squared plus y squared equals r squared. Now again, this is how we find r when we're working with these angles. Now, if we divide through, let's say, by x squared, actually let's divide through by r squared. Let's go ahead and see what this looks like. This would look like x over r, quantity squared, plus y over r quantity squared is equal to r squared over r squared, which is 1. Well, we know that x over r is equal to cosine. So this looks like cosine squared, and I'm going to use the angle of theta, plus sine squared of the angle of theta equals 1. So this is one of your Pythagorean identities. Sine squared plus cosine squared equals 1. Now a couple of quick notes. Cosine squared of theta means to take the cosine of theta and multiply it by itself. Okay, we write that squared up above the cosine. Now, if I want to talk about cosine of theta squared, this means to take the cosine of theta times theta. Okay, so this notation means cosine squared of theta. It doesn't mean squaring the theta. It means squaring cosine of theta. Okay, so now let's go ahead and take this cosine squared plus sine squared, and I like to write it sine squared plus cosine, sine squared plus cosine squared. Order doesn't matter when you're adding. Equals 1. So for this particular case, I think let's go ahead and divide through by cosine squared. Cosine squared of theta. And this will come up with our other Pythagorean identity. Sine squared over cosine squared, if you recall, sine over cosine is tangent. So this is tangent squared of theta plus 1. And 1 over cosine is secant, so this is secant squared, the reciprocal. So there's our other Pythagorean identity. And of course, I'm only showing you one Pythagorean identity here when I talk about this one, but I could subtract 1 from both sides, and I have another part of the identity. Tangent squared is equal to secant squared minus 1. Now let's go ahead and run through the same thing, but instead of dividing through by cosine squared, let's divide through by sine squared. Okay, so let's start with sine squared plus cosine squared equals 1. And last time we divided by cosine squared, let's go ahead and divide through by sine squared. Okay, so let's see what we have here. So sine squared over sine squared is 1. Cosine over sine is cotangent, so this would be 1 plus cotangent squared. 1 over sine is cosecant, so this would be, the reciprocal would be cosecant squared. So there is our third Pythagorean identity. And again, we use these a lot. This first one probably more than the others, but these are all three very important. So I would make sure you know these identities, put them on a note card. You can solve a lot of the problems we were just working with using these identities. I think I showed you a little bit quicker way, but if you go through the Help Me Solve This in my math lab, they might be bringing these up, so I wanted to make sure you're aware of them. I think that this covers the Pythagorean identities. One other thing I wanted to talk about was your calculator. On your calculator, you need to make sure, if you're trying to check answers using a reciprocal, for instance, sine of theta is 1 over cosecant of theta. We know that those are reciprocals of each other. So if I was trying to find out the cosecant of something, I would probably want to find the reciprocal of the sine. Now, reciprocal, we know that x to the negative 1 means 1 over x from algebra. But on your calculators, if you are trying to find the cosecant, you do not use inverse sine. This does not equal 1 over sine. You want to just use the fraction bar, the alpha y equal key that I showed you in one of the earlier videos. This notation right here means arc sine or inverse sine. It does not mean 1 over sine. So be really careful about that if you're using your calculator to check some of the reciprocals. So a very long video, I know, but hopefully I have lots of detail and lots of examples. Again, since this is an online class, I think it's important to give lots of examples and lots of information. You're welcome to fast forward through any part of the video if you already have that information down, and skip to a part where you might need some little extra help. So as usual, if you have questions, give me a quick snap of whatever it is you're working on. You can text it to me and I'll text you right back with some help. Good luck, and again, please let me know if you need any help.